Okay, this is Points, Lines, and Planes, Part 2. I did realize that the first part did get cut off, so let's flip back and just review very quickly. Down here at the bottom, two lines intersect at a point. So this should be at a point. Again, that's because if this is a line and a line, this is where they touch, therefore it would be a point. Then it says two planes intersect in a line. Well, if you think about me taking this paper and then touching it down to this folder, notice that it would create a line right here where it touches. Okay, so down here at the bottom, we would say two planes intersect to form a line. And then if a line and a plane intersect, they intersect at a, well, this piece of paper would be a plane surface. If I take this pen and I drop it down, notice it creates a point. So therefore, a line and a plane intersect at a point. So again, before we do the back, things that we need to remember: 2 points make a line, 3 points make a plane, 3 non-collinear points make one plane. 2 lines intersect at a point, 2 planes intersect in a line, and a line and a plane intersect at a point. So we're going to apply that on the back when we're looking at these examples. So down here it says name 3 points that determine plane J. Well, we just talked about this. It takes 3 points to make a plane. Now we've got to be very careful. Plane J, here's J, so that means this plane right here. So we need to pick 3 points that are in plane J. Okay. Now remember, J doesn't stop, so it would continue up. So if we're looking at points that would be in J, we could pick V, W, Z, or we could even pick U, because it's on this line and we know that these 2 points are in that plane. That means point U is also in point J. So we just need to pick any 3 points that would be in J. Now the most obvious 3 would be V, W, and Z. So we could put V, W, and Z. And then just for posterity's sake, we could go ahead and add point U, because all of those points are actually in the plane. So to name the plane, we would say VWZ, we could say WZU, we could say VZW. Any of these would work to name the plane. Okay. Number 2, name the intersection of planes J and K. Well, this goes back to our rules from the front. Okay, a plane and a plane intersect at a line. So plane and a plane intersect at a line. So we're looking for line something. So here is J, and coming across it going the other direction is plane K, and right here in the middle is where they would intersect. So we know that it's this line right here where they intersect. So in order to name the line, we have to pick 2 points that are on the line. So I could say line VW, or naming that same line, I could say VU, or I could have said UW. Okay, any 2 points that are on that line can be used to name that line. So, number 3, name a set of collinear points. Remember, collinear means same line. So I need to name any points that might be on the same line. Well, those are pretty obvious. The ones that are on the same line are U, V, and W. So I would put U, V, and W. Then it says name a set of non-collinear points, meaning any points that are not on the same line. So I could stay away from V and W because those are collinear, meaning they're on the same line. But I could pick W, Z, and Y. Or I could pick W, Y, and X. Or I could pick Z, U, and Y. There are lots of non-collinear points. So just pick any points that are non-collinear. So let's do W, Z, and X. Okay, but that is not the only answer. Then, number 4, name a set of points other than those in example 1 that are coplanar. Again, remember, this means the same plane. Well, this should be pretty simple. How many points does it take to make a plane? 3 non-collinear. So any 3 non-collinear points are going to be coplanar. So even if they don't look like they're on the same plane, they still count. So let's say I was talking about the obvious one, V, W, and Y. Those are the ones that are on K. So we could do V, W, and Y. But things that are not so obvious, U, X, and Y. That is 3 points. They are non-collinear, so there is a plane that would connect those, even if it's not drawn. So then the same thing if I pick U, V, and Z. Okay, those would also be coplanar. So any 3 points would be coplanar. They would be on the same plane. All right. So let's look at example 2 then, using that same idea. Are points S, O, and M coplanar? In all reality, we could actually cover the picture. How many points did they just name? Well, they named S, O, and M. That is 3 points. Do 3 points make a plane no matter where they are? Yes. So are they coplanar? Yes. My reason is going to be Y, because 3 points make a plane. So let's go to the picture and actually look now. Here is S, O, and M. So this gets a little difficult, but if we were to finish the plane, S, O, and then this cuts across the middle here, the rest of that plane would come down to Q and then attach back to S. So it's an invisible plane that would kind of go through the middle of this, just like if I were to cut this like a piece of cake from O to M, I would also end up cutting it from S to Q. Okay. Now this says how many planes are shown. This means how many are drawn. So you need to think of this like the classroom. Okay, we've got this part, which is the floor. We have this part, which is the ceiling. So that's 2 planes. And then the room is made up of 1, 2, 3, 4 walls. So we would say the 4 walls plus the floor plus the ceiling tells me that there are 6 planes that are shown. Now, is that all the planes that are there? No. We just talked about the invisible plane that went from S to O to M to Q. We could also have a plane that goes from L to O and kind of cuts down the middle here to R and Q and back up to L. Okay? There are lots of invisible planes that are there that are not drawn. All right. So, number 3, name the intersection of plane LON and PQM. So we know it's 2 planes. So we know our explanation is going to be 2 planes intersect at a line. So we know we're looking for some sort of a line as our answer. So I'm going to get some colors out and see if we can't kind of make this help a little bit. LON. Here's L to O and then over to N. So the only way that I can connect those, it must be talking about this plane right here on top. So I'm going to go ahead and trace the rest of that plane. So we're talking about the top of the box. The second part is PQM. So if I connect P to Q to M here, then the rest of that plane would be this one right here. So now I want to look, where do those two touch? Where do they overlap? Where do pink and green touch? Well, if I look, it's right here across this line. Well, that line is L to M. So it would be LM. And again, we know it's a line because two planes intersect at a line. Now, I'm going to go ahead and start another video in case this one gets too long. So this will be part 2. Then we'll go ahead and have part 3 where I do the rest of this worksheet.